One where you have lots of neutrons, say in a supernova explosion, and others where you have a slow flow of neutrons during the stellar life. But the fundamental process is adding neutrons to iron and then adding neutrons to the heavy elements that are created after that neutron capture.
这是一个问题说，那铁之后的元素是怎么产生的？当时教授解释说，铁之后，铁是最稳定的一个原子核了，你再加东西进去呢，它不会缩下去释放能量。我刚刚解释了，那怎么办呢？就是另外的过程，就是你把中子给它加中子进去，它就可以变成比较重的元素，然后呢，经过一些原子核的衰变呢，就可以变成不同的可能性。一种可能就是超新星爆发，超新星爆发的时候提供了能量，所以它的后面的融合其实加中子，这种融合吸热，可是超新星爆发有能量 ，the supernova will provide the energy to for the fission of process， 所以可以不要靠融合，可以还是靠融合，可是你吸热，超新星爆发可以提供很多热量。所以铁之后的东西，其实铁是很前面，都是很前面。我们身上带着那些金啊、铜啊，为什么这么珍贵？应该少。为什么少？因为它不是恒星一辈子才原子核融合产生的，它很大一部分是超新星爆发的时候产生的核反应，所以它含量比较少。可是大自然还是会做得出来。也是很好的问题。来，刚刚是前面还有。举手 ，raise your hand。OK。You want to sit down? Okay. Let's start.
Professor, can the explosion of supernova destroy the Earth? Close enough.
If it was close enough, then there could be a problem because they give out. Some give out gamma rays, nearly all give out X-rays and ultraviolet light. So if there was a massive star close enough to the Earth, it would be a major problem. But there isn't, at the minute, there is no massive star near enough that could explode and cause us a problem. As the Earth goes around the galaxy, it may be that it drifts too close to a massive star, and in the very distant future, hundreds of thousands of years from now, we may be too close to a massive star and be worried about it exploding as a supernova. But at the sun's position now, there are no massive stars close enough that could cause us a problem. But if we were close enough, there would be a problem. It could destroy the ozone layer. The high UV radiation could destroy much of the ozone layer, and then we would be fried by the sun's UV. So it's actually the sun's UV light which might kill us rather than the UV light of the supernova.
问题是说，如果在我们附近的超新星爆发，对我们有什么影响？如果有超新星在我们附近爆发的话，我刚刚举个例子，能量当然会有，还有震波啊等等。那还最简单的就是，即使是它的紫外线，就可以把我们的臭氧层给破坏掉。臭氧层破坏掉，我们就阳光的对我们的影响就很大，所以阳光到时候对我们有很大的危害。但是大家回去可以放心，我们附近没有大质量的恒星，越大质量的恒星越少，所以它彼此之间的距离是很远的。我刚刚讲的那些什么1和9，已经就是离我们很近的大质量，就是最近的，所以它没有。一种可能是地球太阳绕银河一圈要2亿多年了，在这2亿多年里面，有可能我们会走到一个大质量恒星的附近，正好巧不巧，那就决定要死掉。如果那样子，就会有危险。不过都不是大概几十万年、几百万年、1000万年这种会发生的事情。Don't worry, they get to go on.
Yeah. The sun will kill us, but not for another 3 billion years.
Professor, how can we confirm that the neutrinos with detecting the generated from the supernova?
Good question. How do we know the neutrinos came from the supernova? The only argument is that they were coincident with the discovery. They actually came just before the discovery of the supernova in optical light. And they came in a burst lasting over 12 seconds, and we've never seen it again. So it happened at the same time, pretty much the same time as the supernova, and we've never seen it before, and we've never seen it again. And they happen at energies which are different to those that we see from the sun. So those neutrino experiments, where the one in Japan detects neutrinos from the sun. It was built to detect neutrinos from the sun continuously. And as it was detecting the solar neutrinos, then we saw it burst. It's never been seen before or again, and it happened at exactly the same time, or more or less the same time as the optical supernova. So coincidence, almost certainly it was from. There's also some directional information that they have, and they can tell roughly it was from an area of about 50 square degrees on the sky, and they can see roughly which direction the neutrinos came from. And they came from opposite the sun.
刚刚的问题就是说，怎么知道刚刚讲说1987A 爆发的时候有侦测到微中子事件？物理研究很好，就是说我们怎么知道那个微中子是来自那些微中子是来自于超新星？Smart 教授解释就是说时间上是对的，然后平常我们有微中子是来自太阳，所以你知道一天或者平常这个剂量是多少，对不对？那时候会有额外的这些东西。另外就是微中子的那个侦测器啊，它不像望远镜指的很清楚，一些众数啊什么东西，可是它大概还是有一个方向，那个方向是证明说是来自超新星的方向，种种加在一起，让我们相信这些微中子是来自超新星。
They actually came before the supernova was discovered, because the neutrinos come out at the speed of light, but the shock wave goes through the star a little bit slower and doesn't hit the surface until after the neutrinos come out.
超新星的理论告诉我们说，它刚开始要爆发的时候，中间非常非常的密，光还陷在里面还没出来的时候，neutrino因为不太跟物质反应，neutrino先出来，neutrino跑的速度跟光一样快，可是因为它先挣脱出来，所以它先抵达，很短的一段时间，但是它们先到，所以时间上也是对，就是证明说这整个模型啊，这整个理论是正确的。
Do we know the end of the black hole now?
Do we know how black holes will end? So I think the answer is no. It's probable that the black holes that we know of have a star circling them. That's how we find them, through the mass which comes from the star onto the black hole. So they'll probably grow in mass, because they take matter from the star going around them. But they'll probably just live for an infinite amount of time. If there's no other gas around them, they can accrete material slowly from the general material in the interstellar medium. But there's no theories of what may happen to them. They'll probably just sit and accrete and suck matter in very slowly. We do see in most galaxies, in their cores, they have a supermassive black hole, and that probably came as galaxies were forming from stellar mass black holes that clumped together and gave supermassive black holes, which are 1 million to 1 billion times the mass of the sun in the cores of galaxies. So there is some evidence that black holes have joined together and made supermassive black holes in the distant past when galaxies formed.
问题是问说黑洞的未来，不是很清楚的。不过相信说， 黑洞平常它如果吸东西进去，吸进去的话，就变成黑洞。黑洞是一种质量跟能量的状态，就跟水有三态一样，它是另外一种质量跟能量的状态，它非常的密，甚至连光都跑不出来的状态，它钻进这种状态，掉进去就变黑洞，变黑洞那种状态。那另外有讲到，除了恒星质量这种黑洞以外，另外还有是在很多星系的中间有那种超大质量黑洞，它可以有几亿个太阳这样子的质量。黑洞很有意思，是它的质量越大，它的密度质量越低啊。所以这种超大质量黑洞，相信怎么来的，就是可能是小黑洞。刚刚讲，黑洞跟黑洞并在一起，会有一个很大的一个震荡，但是过去以后就变成一个更大的黑洞。那更大的黑洞呢，它比较松，它密度会降低，所以很有意思。现在有看到这种大质量黑洞，相信是从小质量黑洞合并而来。所以你问说将来会怎么样？很久以后，宇宙如果没有发生别的事情，大家全部就变成黑洞。这个我是插一句话，我们的宇宙就是一个黑洞。你把宇宙全部的质量跟我们的大小一算，我们就满足光跑不出去的这个标准。我们就在黑洞里，所以我们跟别的黑洞没办法沟通，我们在里面也活得很好。是那种星球那种黑洞，那种黑洞很密，是要命的，就是那种科幻电影里有这种星球种。I'm telling you, the larger the black hole, the are.
My question is that the Hubble telescope is about to retire, and how the next telescope will improve, and the scientists needs main problem is which way about the new telescope.
So yes, the Hubble Space Telescope will, the plans are that in 2015, 2016 it will probably finish operations. The next telescope is called, that NASA and ESA are planning, is called the James Webb Space Telescope. The Hubble mirror is 2.4 meters. James Webb Telescope will be 6 meters in diameter, so it'll be bigger, but it will be more optimized for near-infrared light. So heat radiation. The reason that the telescope will be, the new telescope will be optimized for that is that as the universe expands, light is redshifted, and so light that when an optical photon is emitted by, say, a distant galaxy, by the time it reaches us, it can be redshifted into the near-infrared, and so we want sensitive near-infrared instruments to probe the very distant universe, galaxies when they first formed. And so the sky is very bright in the infrared, our sky on Earth. So the best thing to do is put a telescope in space and look at light which has a wavelength of about 5 times the light that you can see with your eye. So about 3 microns rather than 700 nanometers. So it's in the near infrared, the heat radiation, the heat area of the electromagnetic spectrum. Also, we can look at stars as they're forming because they're in dust clouds, and near infrared is very good. So the next generation will be bigger, and it will look at redder light. But it will probably be launched. There will probably be a gap between when Hubble finishes and James Webb starts in a few years.
当然，问题是说，哈勃望远镜要退休了，那下一代的望远镜有什么样的想法？回答就是说，哈勃的主镜只有2.4公尺 ，James Webb 的 Space Telescope JWST 呢有6公尺，也大得多，而且它的光学设计跟它的相机啊、侦测器呢，都最佳化在红外线。为什么红外线呢？我们之所以研究宇宙，是在这个领域观测的话，都是看发光的东西。那发光的东西就是恒星嘛，恒星构成的星系。 都在可变光，我们眼睛感光就是用太阳发的光，主要在这个波段变光。可是宇宙膨胀在膨胀，越远的东西它离我们后退的速度越快。杜普勒效应啊，这种宇宙的红移啊，让我们它发的 可见光到达我们这边的时候，都变成红外线光。所以你要研究很远很远的宇宙，就要用红外线，红外线强得多。还有一种就是埋藏在云里面的人星、恒星，可见光也比较看不到，用红外。所以未来这个望远镜还是有各种仪器，但是红外线呢会是它的一个主力。2个问题好了啊，问题都非常非常的棒。不过我们的 speaker
Professor，
Yeah, very good question. So it's a 2-star system. The Type 1a supernovae are not from massive stars. They're white dwarfs, and like neutron stars, they have a maximum mass before they become unstable. They don't produce, white dwarfs are carbon-oxygen stars that don't produce energy by fusion, but they're held up by this degeneracy pressure. You can't squeeze the particles closer together than a certain amount. So the maximum mass to hold up that a white dwarf can be is 1.4 times the mass of the sun. So if you have a binary star going around a white dwarf and it puts material onto the white dwarf, it gets bigger than 1.4 solar masses and then it explodes. So you have to have 2 stars to do this. It might be 2 white dwarfs that merge, or it might be a white dwarf plus another normal star like the sun going around it that puts material on it. And we still don't know which of those 2 produce white dwarfs. Maybe both types of systems.
问题是说，演讲没有讲到的 EA 型的超新星是什么样的情况？司马教授解释说，小于1.4倍太阳质量的那种恒星，它的核心对不起，小于1.4倍的那个核心啊，它缩下去呢，可以被白矮星撑住，用那个压得最紧的位置撑住。可是大于1.4倍太阳质量，你就会把电子压进去，因为撑不住了，就把电子压进去变中子星。所以1.4倍以下的成为白矮星，1.4倍以上成为中子星。那在一个双星系统里，它原来是个白矮星，本来没有很胖，小于1.4倍，可是有别的邻近的星球，可能是一个白矮星并在一起了，绕并在一起，或者是一根正常的星球，它的东西啊，被它外面给吸进来，所以它就质量变大，超过了那个1.4倍的那个临界的极限，那个极限呢，它就爆发成超新星。因为是临界，它从不能变成超新星到可以变成超新星，是一个固定的条件，所以这些超新星爆发的时候亮度都差不多，它才能够当做一个标准的光带去研究很远很远的宇宙。所以讲到这个 expanding universe， 宇宙在加速膨胀的这一件事情 ，accelerating 就是用超新星 A 来当标准的光。OK， 最后一个问题 ，One last question. Who has the honor?
I'll take 2. I'll take these 2.
是那个太阳在核融合的时候，它是氢变成氦，然后一直到铁，但是中间每个元素都会经过嘛，还是会被跳过
？Yes, at the center of the sun, the nuclear fusion from hydrogen all the way to iron. Does every element get produced, or some will be skipped?
So not every elements are produced. So for example, lithium, beryllium, and boron are produced but immediately destroyed in hydrogen to helium burning. Those were probably created. The elements those elements were probably created in the Big Bang, but they're destroyed and they're skipped. So if you look at the the abundance of elements. There's lots of hydrogen, lots of helium, hardly any lithium, beryllium, and boron in the galaxy, and then lots of carbon. There's also nitrogen, which is not formed in burning of carbon to oxygen, but it's formed in a different process. So all of those are, all of the elements up to iron are formed in some way, but many of them are less abundant than carbon, oxygen, magnesium, silicon. The ones that are clearly on the chain of burning between helium, carbon, the oxygen. Anything that's a if you look at the periodic table, anything which is a multiple of 4, which has the same number of neutrons and has double the number of neutrons as it does, the same number of neutrons as it does protons, like helium. Anything which is a multiple of 4, they are the most abundant elements we see. And those are the most common nuclear processes, the most frequent. And the others are formed in different nuclear reactions, which are just less frequent.
问题就是说，回答就是说，在周期表上的，在铁之前的元素，我们刚刚讲是恒星的核子反应。可是核子反应，大家讲氢变成氦，氦后来会跟别的东西反应。我刚刚回答就是说，只要是4的倍数，那个原子量，它只要是4的倍数就比较多，比如说碳啊、氮啊这些东西就没了这些。 其他的呢，它的反应就比较少，所以它的量就比较少。所以，而且还有衰变，就是它可以从一个原子核，然后衰变成另外一个等等其他元素。这些我们叫弱作用力的贝塔衰变、贝塔片，加上这些东西加在一起，造就了周期表上这些种种。但基本上的要素就是越简单就是越多的，越简单构造越简单的。 然后原子序第2个、第3个，刚刚讲到锂、硼、lithium、boron and beryllium。
Yes, lithium, beryllium, boron。
base 这几个元素呢，就不是，因为它在锂是7，它没有办法靠这些东西来造出来，所以这些元素就是大批量的时候做出来比较多的时候呢，产生它的过程的反应比较少。 摧毁它的很多，因为它可以跟别人很容易去做的，所以那些是很特殊的元素。所以我们在量恒星年期的时候，我们会看它的锂元素。如果有看到锂的元素，锂期的很少，它还没有被摧毁掉。Okay, one last question.
超新星的爆炸对周围对土星是有什么影响？
或者说超新星的爆发跟宇宙背景辐射的互相的影响在。Okay, the question was, how does the supernova explosion affect or vice versa with cosmic background radiation?
So the cosmic background radiation is at microwave wavelengths, and supernovae tend to be bright at much shorter wavelengths. They don't really emit much microwave background radiation, so I don't think they interact very much with that. I don't think you can see any effect on supernovae either affecting the cosmic microwave background or affecting measurements. For example, I guess one thing that one might be worried about is that if supernovae were bright in microwaves, they might affect the measurements of the cosmic microwave background because they're frequent in the universe, and one might pick up microwave radiation from them. But they don't emit very much radiation in the microwaves. They mostly emit in the ultraviolet, the optical, near infrared. So they probably wouldn't affect any microwave background radiation measurements.
宇宙微波背景辐射是宇宙就大霹雳之后宇宙膨胀余温啊，四面八方都有的辐射。那超新星爆发是局部的恒星爆发的现象，多半都在可见光、紫外线、紫色这样。它在微波那边比较没有辐射。唯一Smart教授能够想到的影响，就是如果超新星的辐射在微波够强，那我们在量宇宙背景辐射的时候，超新星的辐射会影响我们的测量。但是事实上是超新星地方它少，它就是个别的局部的区域。各方面就是它在微波其实不太辐射，很弱，所以应该没有什么影响。OK。好，谢谢各位今天的光临。我觉得，谢谢大家哈。我每次都说，一个演讲好不好，用他后面得到的问题多不多，可以来判断得出来。那今天的演讲一定是非常成功的。我上一次来这边，我已经感动了好几天，这次又要回去让我感动好几天。谢谢大家，
谢谢大家。
我跟Smart教授讲过了，他还会在这边有些你不好意思问的问题，可以现在上来问。刚才有问问题的，你都可以拿一张海报，签名海报，价值无限哈。但是就是他要签要花点时间，而且我请他坐下来哈，他站了3个钟头了。那我请他坐下来签，然后你们有问题啊，